afternoon, students. So we will start work power energy. So we'll start with work. Okay, point number 1, work is equal to F vector dot S vector. The result of dot product is what?
Cosine of the
Okay, magnitude of force, magnitude of displacement, and cos theta. Will it be vector or scalar? Okay. Third point, joule. Unit is joule. Fourth point, mLT raised to minus 2 into this dimension. Its dimensional formula is ml square t raised to minus 2. Dimensional formula of work. Okay, it doesn't have any direction. Okay, work doesn't have any direction, but sign is there. Work can be positive or negative. Okay, work can be positive or negative. Done. We will start learning this by doing problems. Just by doing problems we will start the chapter. So when we study about work, it is F dot S. So work done by which force, that is important. If they say about the force, then only we will be able to clearly give the answer. Correct or what? Fine. Suppose now case F is acting in this direction, force is also acting in this direction, then what is the theta angle between force and displacement? 0. We will be getting work is equal to F into S. Work is equal to force into displacement is only for this case alone, right? Second case, if the force is in this direction and displacement is in the opposite direction, then what is theta? 180 degree, correct? In that case, cos 180. What is cos 180? Minus 1. So this is going to be minus S. Correct? Fine. So question number 1. Okay, so this is a mass and force is acting in this direction. Okay, this is 10 kg. The force is equal to 50 Newton. We displaced the mass to point. This distance is 5 meter. Okay, so what is the work done by force? External force. What is the work done? External force. Quickly, come on. F dot S, Fs cos. What is the angle? All these basic things, just because if someone is there without this knowledge, they should understand. Okay, so please respond so you will move fast. Okay. So this is just Fs. This is going to be 50 into 5. This is going to be 250 joule. Okay. Okay. Right. Suppose same question, same situation. Here is equal to 0, 1 is given. Okay. Then what is the work done by frictional force? What is the work done by frictional force? Hmm? 50. Any other answer? Any other answer? Sign? Understood? Okay, done. What is the answer? Minus 50. Correct? Few. See, look here. Now, work done by friction is nothing but frictional force dot the displacement. Now, in which direction frictional force is acting? Suppose if this is frictional force is acting in this direction, this is acting in this direction. So what is frictional force? Frictional force is equal to N. So if this is mg, this is the normal reaction. So mu is given as 0.1. What is the mass? 10. So this is going to be 10. Correct or what? So 10 Newton. 10 Newton is the frictional force. So 10 into the displacement is 5 cos what? 180. So this is going to be minus 50 joule. Correct or what? So which work? Summa work is equal to what? We cannot say. Summa what is work? One force is there. We cannot say like that. Work because of which force? Frictional force. Work due to external force. Likewise, we need to be very clear about which force and what is the angle between force and displacement. Done? Fine. Okay. Third question. 10 kilogram displaced the force applied is 50 Newton. What is the work done by gravitational force? Come on. 0. What is the work done by gravitational force? Enna Mukesh? 0. Work done by gravitational force is 0. Okay, let us see. What is gravitational force? mg. Acting in which direction? In this direction. What is this angle? 90 degree. So now mg dot this displacement s. So mgs cos what? Force displacement. The angle between them is 90. Okay, clear? What is the work done by normal reaction in this case? What is the work done by normal reaction in this case? 0. Okay, correct or what? Normal reaction will be acting in this direction. Displacement is acting in this direction. So just suppose if the normal reaction is, this is going to be n dot s. So ns cos 90. Correct or what? Normal reaction and displacement. The angle is 90 degrees. This is going to be 0. Clear or what? Okay, done. Fine. Work done by this case. What is the work done by gravitational force in this case? Just for easiness, I am making this angle alpha is equal to 30 degree. Okay.
Here, what will be the net force acting on the net work done on the body? This minus this.
If two forces are mentioned, frictional force and external force, then that is the net work done. Gravitational force, normal force, everything is considered. If they ask the net force, simply we will have to add all of them, including negative signs. All of them are 0, so no worries.
So if we have to add them, this be minus 1.
The work is scalar, simply we can add. Yes, what is the answer, children? 250 joules. Okay, right. So 250 root 3. Any other answer? If you get any other answer, please tell me. So what is happening here? Work done by gravity. So mg is acting in this direction. Mg is acting in this direction. So this is going to be mg cos theta, and one component is acting in this direction. This is going to be mg sin theta. Correct or what? Mg cos theta and mg sin theta. So work done by gravitation, if I want, I can take exactly also taking this angle, our wish, but I am going to show you separately. So this is nothing but mg cos theta. This is one force, if we consider that as one force, into this displacement, if it is 5 meter, into cos 90 if I take. This is one force. Okay, this mg I have resolved into perpendicular component and parallel component, done. Plus again mg sin theta acting in this direction into displacement is 5 meter into what? Cos 180, because force is acting in this direction, displacement is acting in this direction. Nitish, are you able to follow? Tangam, Sudarshan? Okay. This is going to be, what about this one? This is 0. So here 10 this is going to be minus 250 joule. Correct or what? Minus 250 joule. Then suppose if I need to take, if I want mg directly, if I want to take mg directly, okay, this is the direction of mg. Okay, just okay. Okay, so this is the direction of mg. This is 30 degree. What is this angle? 90 degree. What will be this one? 60 degree, correct? mg is acting in this direction, this is the direction of displacement, correct or what? So what is the angle between work is equal to F dot S? F is nothing but mg 10 into 10 into 5 into cos how much? This is the direction of displacement and this is the direction of what? 120. What? Direction of force. So if I take this angle, how much will be there? Cos 120. Okay, so this is going to be what? 500 into minus. Okay, so understood how this cos 90 plus 30. So this is going to be sin 30. So if I what children who do not know, okay, first, second, third, fourth, 90 degree comes here. So 90 plus 30 means here. What is this? Cos 90 plus 30, all silver tea cups. So if all will be positive here, here only sign will be positive, but it's cos. So definitely this is going to be negative. Since this is in this quadrant, we will be putting a negative. So this is going to be 500 into what? Minus 1 by 2 minus 250 joule. Okay. So if two vectors are acting, okay, if this is one vector, this is one vector, how we will be able to measure the angle between two vectors? See, if this is one vector, this is another vector, either we can measure like this, otherwise we can measure like this. Okay, always choose the smaller angle. In the vector basics we have discussed, choose the smaller angle do. Correct or what? Any confusion? Done? Clear? Fine. Same question. We'll do it again. We'll draw it again. Okay. This is clear? Okay. Okay, see now, okay, alpha, mass, what weight 10 kg, 10 kg, displacement, meter, this alpha is equal to 30. What is the work done by normal reaction? Work done by normal reaction will be 0. Why? Because normal reaction mg was acting exactly towards the ground, but normal reaction will be acting perpendicular to the plane. If this is the plane, this will be the normal reaction. If this is the plane, this is the normal reaction. If this is the plane, this is the normal reaction. So always for normal reaction, the angle with the plane will be 90 degree. Correct? Pakka? Understood. Right. Okay. Okay, what is the work done by gravitational force on both the masses? Okay, what is the work done by gravitational force on both the masses if 2 kg moves down by 3 meter? This one, work done by gravitational force on 2 kg. How much? 20. And work done by gravitational force on 1 kg is how much? Minus 10 joules. Okay. Any other answer?
Hmm? 30 joules.
30 joules. Which one?
So B overall, sorry.
Oh, not overall.
30.
What is the work done on this? How much? What is the work done on this? Sumara alla sollakudadu. Suma, you can say. Whatever answer you are getting, tell. No issues. Okay. But what I need is separate. Okay, so let us see. If this is 1 kg, then work done by gravitational force on 1 kg is equal to what? mg. What is m? Into g is 10. This will move up by 3 meter. This will be the direction of mg. So this is going to be 311 into minus 1. So this is going to be minus 30 joule. Correct or what, Aslam? Okay, and work done by gravity on 2 kg will be what? Here we have with a displacement of 3 meter. So 2 into 10 into displacement is 3. This is going to be cos. So 60 joules. This is the work done by gravity. Correct or what? Fine.
Acceleration will be g by 3 no sir for that system.
But that is why I will solve for tension also, then you may get it. Okay, so this is the work done by gravity alone. Now let us see. Okay, this is copied, no, all of you? Okay. Please do this question. Work done by tension. Work done by tension force on 1 kg and work done by tension force on 2 kg. Please do this. Okay. Okay, done. Aslam understood. Okay. See, children, look here. So tension will be, if mg is acting in this direction, tension will be away from the body. All tension forces will be what? Away from the body. So same wire allava. Okay. This is back of Vikram. This is front side of Vikram. Correct? Same wire, na? Same wire, same wire. So this tension and this tension both are done. So if you want to find the tension, you can, for this kind of case, here 2 m1 m2 divided by m1 plus m2. 2 m1 m2 divided by m1 plus m2. Okay, into g. For the other case, that was different from this. For that 2 will not be there. So this is the formula, or otherwise this is moving, this is coming down with the coming for 3 meter, right? So acceleration will be in this direction, here acceleration will be in this direction. So T minus mg is equal to what? T minus mg means T minus 2g is equal to what? 2a. That side 3g minus t is equal to what? 2a. Correct or what? Okay, 2g minus t. Okay, in which direction acceleration? That force will be more. So if we add them, this t will be cancelled off.
2g minus first equation, 2g minus t.
Wrong, completely wrong. Okay, so this is going to be t minus 1g is equal to 1a, and the other one is mg minus t is 2g minus t is equal to what? 2a. So when you add them, what will happen? This is going to be g is equal to 3a. So acceleration is going to be g by 3. So if we put here, we will be able to find tension T is equal to what? A plus g allava from this equation. So this is going to be what? G by 3 plus g, we will be getting what? G by 3. Now look here, you will be getting 2 into 1 into 2 divided by 1 plus 2 into g. What is this? 4 by 3 g. Same thing will be getting, but how much time we need to spend here? So it's the same case. If you get, do this formula. Okay, done. So we got the t values. T value is what? 4 by 3g. Okay, done. Now work done by tension. So work done by tension on which 1 kg is equal to, this is the direction of tension. Okay, so 4g by 3 means 4 into 10 by 3 into, which is the direction of displacement? This is the direction of displacement. I could put 3 here. This is going to be cos 0. Correct? So potato 40 joule, done. Same way for work done by tension on 2 kg is going to be, this case 2 kg tension 4 into 10 by 3 into tension is in the upward direction, displacement in the downward direction. So this is going to be 180. I will be getting minus 40 joule. Clear? A simple problem. Okay, so many questions. Work done by gravity on 1 kg, 2 kg, work done by tension on 1 kg, 2 kg. If clarity is there, things are easy. See children, we are studying basics. We are studying the very basics. If you are very strong in work power energy, throughout the physics, this will help you. In electrostatics, in potential, everywhere it will come. Children, in electric potential and capacitance, if they want, they can ask work done by external force, work done by electric field, mathemati kekala. What done by external force? No problem. Directly you are studying that. Work done by electric field means, see what you are doing actually. Work done by external force is equal to minus of work done by electric force. You are putting this condition and we are solving this. So exactly opposite answer will come if work done by electric field is asked. Negative will come extra. So if you are strong here, everywhere, wherever potential energy, kinetic energy, work, whatever, wherever it comes, you will feel comfortable. So this is fundamental. Whatever simple doubts you have, you can ask. Actually work power energy is scheduled coming Thursday. This chapter is scheduled coming Thursday. We have enough time. We are much ahead. So whatever doubts you have, please ask, clear it and proceed. Okay. You can say. Sit.
The gravitational force is coming, sir. Opposite only tension, sir. Then sign if reverse means will be continuous, sir.
Purila, ask again.
Sir, the gravitational force is acting downwards, sir. Tension force is going upwards. So both are reverse, sir. So if we change the sign order, we will same of, sir.
The sign we need to take between what and what? Copy. This is done. Shall I erase? Nitish, copying. Done. Okay. See, what you are asking is, this is mg, this is tension. Okay, what is your doubt?
Gravitational force was acting downwards. Now tensional force is acting upwards. Then the only direction has been changed, so we can reverse the sign.
Only direction has changed. Direction is already changed, so
sign can be reversed.
Sign can be reversed. Sign can be reversed. Tension and mg are same. Tension and mg, magnitude of tension and magnitude of mg. Whether no. So then how simply we will reverse the sign and find the answer? I will explain. This is one, we about 1 kg mass or 2 kg. How much is displacement? In which direction? What you are trying to find? Force due to tension or force due to gravity? No, work due to gravity or work due to tension? Which one you are interested? Work due to tension. So work due to tension na tension into displacement 3 meter into cos 0. So what is that? 4g by 3 we go. 40 is the value of tension. Correct or what? 40 by 3 into 3. Cancel 40 joule. Is it clear? Now anything else? அவ்வளோதான். அப்போ முன்னாடி என்ன கேட்டீங்க? இல்லை, நோ ப்ராப்ளம். யூ கேன் டான்ஸ். உங்களுக்கு டான்ஸ் ஆடணுமா? If you want to dance, come. You do moonwalk, gliding and all. Go and sit. பண்ணுமோ? So anything தங்கம்? இனி 2 kg இந்த ஆள் தான். Clear? Fine. Any doubts, children, regarding?
It was done by the gravitational of the system.
Just add them along with the sign. You tell me what is the work done by gravity on 1 kg?
62.
Work this minus 30 2 kg apro this one tension 40 2 kg minus 40. Add them. This is the net work done. Add them 30. If you want to know net work on the system, 30, just add them. This is not vector, this is scalar. Simply you can add, maintain the signs. If you want to do net work on 1 kg or 2 kg, then that alone you can do. Okay, ellam wish viruppo. Correct or what? Okay, children. So these kind of questions, one category is this kind of questions. Figures will be given, okay, and we may have to do like this. These are the fundamentals, just to understand how it works. Okay, now again further easy things. Inga summer basics done. So 2 minus 4k. This is the force. Okay, so this force displaces a body from 2, 1, 0 3, 4, 2. Find the work done by the force. Find the work done by the force. இங்கொரு இந்த கிளாஸ் ரூமுக்குள்ள ஒரு சேர் போட்டால் தப்பு இல்லை. Got? அப்படியா? ஓகே. enna kedikudpa? What answer you are getting? 3 joule. So work done is 3 joule, correct? So work done by the force is F dot S. Okay, now about this one, this is actually position vector. Okay, position vector, the position of the object is given x, y, z. So 2i plus j plus 0k. This is the from which position we are changing. So suppose if this is the initial position, shifting to second position, r1, r. The difference between them, this is the displacement. So what is r3? Displacement is going to be r2 vector minus r1 vector. This is going to be I plus 3j plus 2k. So F dot S is equal to 2i plus 3j plus minus 4k. This dot what? I plus 3j plus 2k, done. So 2 into 1, 2, 3 into 3, 9, 4 into 2 minus 8. This is going to be 11 minus 3. Understood? Clear? Any doubt in this? Okay, wherever you get position vector, same approach. Done? Clear? We'll do another question. Doubt? Illa. Yes sir, no sonninga. Okay. Okay children, shall I erase this? All of you? Okay. Another question. Mass of a body 20. Okay, this is at rest. Okay, a force is applied on it. Force is applied on it. How much? 5 Newton. Force is applied on it, 5 Newton. Work done in 1 second. What is the work done in 1 second? Five by 8. All of you got it? Got? Okay. What we need here? Work is equal to F dot S value. Okay. Yes, inge not given. அப்ப என்ன பண்ணணும்? கண்டுபிடிக்கணும். So S கண்டுபிடிக்கிறதுக்கு என்ன இருக்குது? பொசிஷன் வெக்டர் இல்ல. என்ன இருக்குது? பொசிஷன் வெக்டர் அதுவும் இல்ல. அப்படி டைரக்டா கண்டுபிடிக்க முடியாது. சரி, இப்படி பார்த்தா அப்புறம் நமக்கு ஞாபகம் இருக்கிறது என்னது? S is equal to V into T. அப்படி பார்த்தா ஃபோர்ஸ் இருக்குது. அப்ப முடியாது. அப்ப என்ன பண்ணலாம்? UT plus half it is equal. சும்மா போட்டு பார்ப்போம். ட்ரை பண்ணலாம். என்ன நமக்குள்ள தானே? nothing சும்மா ட்ரை பண்ணலாம். So this is at rest இல்லையா முன்னாடி? பட்டாக், this is 0. So this is going to be half in. So force கொடுத்திருக்குது mass, சந்தோஷம். Okay, so this is 5 divided by 20 into what? For 1 second. So when you will be getting what? 5 by 40 displacement we will be getting. Correct or what? So put here. So F dot S. So 5 into 5 by 40. Correct or what, pa? 25 by 40. 5 by 8 joule. Yes. Hold on. Okay, சும்மா என்ன கண்டுபிடிக்கணுமோ that we need to try. அவ்வளவுதான். Clear? Nitish, able to follow? Okay, another question. F is equal to x square. Okay, displaces from displaces from 1, 2, 3, 4. What is that? I. X square I. Hemanta. Hemant. Okay. Any other answer? என்ன கிடைச்சது? பாப்பாஸ் அண்ட் பாப்பீஸ். அஸ்லம் பாப்பி என்ன கிடைச்சது? பரவாயில்ல பாப்பா. செட்ரிக் அவர்களே. ஓகே, என்ன கிடைச்சது? பார்க்கட்டும், நம்ம திமிரோட சில பேருங்க இருக்கு. சும்மா சும்மா. அப்புறம் மதுமதி. மதுமதினு யாரும் கிளாஸ்ல இல்லைல்ல? ஐ கேன் சே ஆன் மை விஷ். கிளாஸ்ல யாருமே இல்லைன்னா அப்புறம் சொல்லலாம். ஓகே, மதுமதி and all. Okay, see children, anyone is getting the answer? கிடைக்கிற மாதிரி தான் சொல்லுங்க. Anyone is getting, tell the answer. சாக்லேட் வேணுமா? இல்லை, கரெக்ட் ஆன்சர். சாக்லேட் வேண்டாமா? ரொம்ப குழந்தைகள் நான் மட்டும் பேசிட்டு இருக்கு. இப்போ the thing is like this is constant force or variable. So the thing is work done is equal to integral. Formula is x1 to x2 fx dx plus integral y1 to y2 fy dy plus integral z1 to z2 fz dz. Follow this formula. Thing is nothing but the concept of this thing is nothing but the force is variable. So force is variable, so immediately we cannot do. Okay, with respect to distance, what is this? When x is equal to 1, the x component of force is 1. When x is equal to 2, x component will be 4. X is equal to 3, it is 9. Here 1, 2, 2, 4, 3, 6. So this force keeps on changing. So 1 meter எடுக்கும்போது whatever be the work done, that is completely different for the second meter. Correct or what? So that is why what we will be doing, the concept is we will be finding the work done due to the small part, then we will be doing the work done by the second small part, then full. So எப்பவுமே இதே ஆட் பண்ணிட்டு இருந்தா என்ன ஆகும் நம்ம லைஃப்? So that is why we are using someone who is found integration and given to us. So this is making our life easy. Maths படிக்கும்போது என்ன தோணும்? If this chapter is not there, life எவ்வளவு ஈஸியா இருக்கும் தோணும். But in real life, actually, honestly speaking, without this, life would have been difficult. That is why. Okay, done. So work is equal to, dear children, nothing but this is x1, this is x2. So integral 1 to 3 x square dx plus So here actually this is nothing but dxi. This is actually dxi. உண்மையா சொன்னீங்கன்னா how x square I dot dxi இப்படி தானே வரும். Okay, anyway this will become what? 1. So we don't consider them. Simply we put x square dx. Then this is y1 and this is y2. So this is going to be 2 to 4. This is going to be 2y dy. So integrate this x cube by 3, putting the limits 1 to 3 plus 2y square by 2, putting the limits 2 to. So if you simplify this, this is going to be 3 by 3, 27 by 3 minus 1 by 3 plus. So this is going to be 16 by 2 minus 16 minus 4. So this is going to be 9. How much is this? Plus 12 minus 1 by 3. So simplifying this, what will be getting? 62 by 3 plus. So this is the answer for this question. So whenever we get variable force, easy now, nothing is there. Put the limits, integrate it, get the answer. Correct? Correct or what? Done? Okay, you need one more question? Same type, Venda? Vendama? We will go to the next type. Done. Okay, see children, put the heading conservative and non-conservative force. Conservative force. So first thing which we can say is conservative force are those type of force where if we do work against conservative force, it will be stored as potential energy. Suppose this is okay, this is here. Now if I lift it up, okay, I am doing work against gravitational force. So if I leave, this potential energy is immediately converting into kinetic energy. Okay, that is conservative force. Gravitational force is conservative force. That is the reason the work against it is storing as potential energy. Okay, now bow and arrow, elastic force. So when we pull with the arrow, what is happening? I am doing work against elastic force. So if I just leave it, what will happen? This will go. So this stored potential energy will be converted into kinetic energy. Okay, so inga oru electric charge, okay, or positive electric charge or positive electric charge. Ivungalukkulla life was going very nicely. Okay, very good friendship, thick friends. Okay, என்ன சொல்லலாம், மச்சான் அவ்வளோ ஃப்ரெண்ட்ஷிப். இன் பிட்வீன் சும்மா ஒரு நெகட்டிவ் சார்ஜ், ஓகே, கேம். ஓகே, நெகட்டிவ் சார்ஜ் கேம். So this is positive charge and this is negative charge. Okay, plus q plus q. Sandosam. Okay, okay. Now someone felt and they kept a minus q charge here. Okay, minus q charge here. So now someone from outside trying to bring out this negative charge. So romba kashtappattu minus q charge brought here. Okay, so okay, okay, very much difficult. Okay, oh no, I am doing work against what force? Electrostatic force. Electrostatic force is conservative force or what? Conservative force. Oh, I'm going to leave. What will happen? Both of them will attract. Thinking that they will get. What they will do? Minus q charge will go here. Because of inertia, it will go. Again, they will attract. So these components will cancel out. After reaching here, again it will come back. Again it will go here. Simple harmonic motion. Simple harmonic motion. Plus q and this plus q will wait till the world ends for this minus q charge. They won't get. So this will happen. Okay. So I am pulling this. When I am leaving, it's going back. No. Potential energy. Leaving, becoming kinetic energy. So electrostatic force is a conservative force. Okay, hippo. Frictional force. Frictional force. All of you please look here. Okay, please look here. Okay, it is kept here. Going to do work against frictional force. Okay, very rough area, very rough. Doing work against frictional force. Going to leave. Went back or not? Not going back. What I thought, when we will bring it here, no, it will go back. It is not going. Correct or what? So those children who are seeing online, suppose see, this is a surface. This is a surface. I am keeping this pen here. I am doing work against the frictional force on my hands. So just like the previous cases, now I am displacing. It is not coming back. It is not coming back. So the difference between conservative force and non-conservative force is, if I do work against conservative force, that will be stored as potential energy. If I do work against conservative force, nothing will happen. So conservative force, example, gravitational force, electric force, then elastic force, okay, then non-conservative force, frictional force, viscous force. Clear? Okay, done. So this is the example. Okay, this is the example. Okay, one important thing is, okay, work against conservative force is path independent. Work done against conservative force is path independent. Path independent. Whichever way we do work, okay, it doesn't make any difference. Already you have covered electric potential. Suppose if this is a point, charge is kept at a distance r. If this is a point, from in the charge is brought here. So this charge should be projected and go. It should be reaching the destination. No, it can come in any way, because we are doing work against conservative force. Now I shall prove it. Say for example, this is one position, this is another position. Suppose if this is 1, 2, 3. Okay, I need to take a mass from position 1 to position 2. Okay, so mass I need to take from position 1 to position 2. Suppose if this length is L and if this is alpha, this length, can I say this is L cos alpha. This length, what is this? Okay, so can I write this as L sine alpha? Any confusion? Clear? Okay, done. Now gravitational force from 1 to 2. Okay, I need to bring this mass from 1 to 2 through which way? 1 to 2 directly. Okay, so what is the gravitational force? And this is going to be what? mg. This is going to be mg cos alpha. This is going to be mg sin alpha. Due to this component, work will be what? Due to mg cos alpha component, work will be what? Doubt irundha sollunga. I will ask. What I am asking, see, mg is this. Mg is a force. For our easiness, we have divided this into mg sin alpha, mg cos alpha. Now it is just like two forces are there for gravity. So the work done due to mg cos alpha will be what? 0. முன்னாடி எல்லாம் வந்து ஏதாச்சும் தெரியலன்னா இப்படி சொல்லியிருக்கலாம். இப்போ மாஸ்க் இருக்குதுனால அதே ஒரு சௌகரியம். Doubt ஏதாச்சும் இருந்தீங்கன்னா it should be crystal clear. It should be crystal clear. If you have any doubt, please correct it. Okay, so 1 to 2, I am interested in mg sin alpha into L into what is the angle between cos 180. Is it correct? All of you agree? Mg sin alpha into L into cos 180. So this work done is nothing but what? This will become minus 1. So minus mg sin alpha minus mgl sin alpha. So this is from 1 to 2. Correct or what? This is from 1 to 2. Right. Now we will take from 1 to 2, 2 to 3. 1 to 2, 2 to 3. We will take this path. So if we take this path, that is work done from 1 to 2, 2 to 3. So this is going to be mg is acting in this direction. Displacement is in this direction. First one will be 0 or what? Okay. Now here mg is acting in this direction. L sin alpha is acting in that. Plus minus mg L sin alpha. What about this one and this one? Same or what? So work done by conservative force will be equal whatever path we take. Okay, fundamental idea. Okay, so this is the reason the potential is also, in potential also work done will be what? In equipotential surface, no. Work done will be what? 0. So that is the reason. Whichever way we take, things will be path independent. Done. So this is the reason behind it. Clear? Now suppose the same example, if I try to do work done by friction, work done due to friction, with one statement things will go wrong. Here if mu is equal to 0.1 and here if mu is equal to 0.2, things will become different, right? Correct or what? So non-conservative force, this is path dependent. Path dependent. Clear? Clear alla? Doubt irukka? புரியல. This mass taking from 1 to 2 directly. Second, now this is one path. This is another path. So 1 இலிருந்து 2 க்கு கொண்டு போகும்போது this is L cos alpha. mg ஆக்ட் ஆகுது. 90 டிகிரி வந்ததுனால mg L cos alpha 0 வரும். இனி இங்க வரைக்கும் வந்திருக்குது. work done 0. இங்க இருந்து இங்க போகிறதுக்கு mg கீழே. mg is acting in the opposite direction. This is the displacement. So mg into L sin alpha. Cos theta varum, that cos theta will be cos 180, adanaala da inda minus. So this answer and this answer both are same illaya. So ippadi pogumbodum ippadi kondu varumbodum work done is same. Adanaala we say path independent. Eppadi kondu ponalum seri work done by against gravitational force, electrostatic force, elastic force, all these things will be path patti kavalaye venda. That is what initial point and final point, right? Clear or what? Done. Shall I ask you one thing? See, this is point 1, this is point 2, we came back to point 1 again. Okay, so what will be the work done? 0 in both the cases. Both in conservative force and non-conservative force. Work done will be 0 in a round trip. Okay, in conservative force. In conservative force. So that this work is equal to F dot S. This concept also works correctly for conservative force only, because here this is displacement. When we say shortest straight line path, ipdi ponalum in this way if we go, this will be displacement, path independent, all these things will work correctly for what? Conservative force. Correct? So that is another point. That is another point. Clear? So in non-conservative force, work done in the round trip is not equal to 0. Clear or what? Now we need to know how to find whether a given function is a conservative force or non-conservative force. Okay. Suppose if we get a function, then in that understand this. So f is equal to xi plus yj. So this is conservative okay. So in this kind of way, if they ask, okay, so suppose if we get f is equal to fx of I plus fy of j plus fz of k. Suppose if we do dou f of x by dou y, differentiating that x part with respect to y, and take each one. If this is equal to dou f of y divided by dou x, what is the difference between d and dou? Partial differentiation. When we are differentiating with respect to x, y and z must be considered as constants. So when you differentiate y, that will become 0. It will not be 2y dy by dx. It is not like that. Clear or what? Understood? One condition is this. Now dou f of x divided by dou z, if it is equal to dou f of z divided by dou x, number 1. Number 2. Number 3 is dou f of z by dou y is equal to dou f of y divided. If these conditions are met, then that is conservative. Otherwise it is not conservative. Okay, now we will see. First condition, only x and y terms are there, so we need to check only that one. Okay, so dou f of x is what? X with respect to y. Whether this is equal to dou by dou x of y. So here f of x is this one, f of y is this one. What is dou x by dou y? Differentiation of x with respect to y, considering this as constant. This is going to be 0. Differentiation of y with respect to x, what? 0. Correct or what? Is there anything else to check? x term, z term is not there. So this is actually what? Conservative force. Clear in this?
f of x with respect to y na 0 ஆயிருமா சார்?
அப்படி இல்லை. இப்போ say if I give another example, f is equal to xyi plus yxj. If such a function, then dou f of x by dou y, if I do, இது என்னது? What is this? I ஓட கூட என்ன வருதோ, that is what is the force component in x direction. That is why we are writing f of x, fx. So dou f of x by dou y is nothing but dou x of y by dou y. When I differentiate this, what will come? X. So need not be this will be 0 always. இங்க y இருந்துச்சுனா it will not be 0. x இருக்கும்போது this is simply d by dx of 3 is what? 0. This is constant layer. So same way with respect to y, x and z will become constant. That is what is partial differentiation. Clear all of you? So that is all. If I differentiate this y dou x, if I do that, what will happen is dou by dou x of yx will become what? Y. So this is not equal, not conservative. This is not conservative, but still not 0. Clear? Understood? Fine. Children?
Dependent on x na x complex
It's just what we need to do. After checking this condition, if this condition is fine, we can directly mark this is conservative force. All these options are just for making options. Okay, clear? Done? Okay, suppose this force or non-conservative. Understood? Get it out? Understood? Mana? Supra. செம்மையாக புரியுது. செம்மையாக புரியுதுன்னு சொன்னால் எப்படி சிரிப்பு? அவ்வளோ புரியல இப்போ. புரிஞ்சுதா? நிதிஷ் பக்கம் போகும்போது நிதிஷ் இப்படி காமிக்கும். போன்னு சொல்றதுக்கு பதிலாக எப்படி காமிச்சிங்கன்னா ஐ வாண்ட் கோ நியர். ஓகே. So what about this one? Dou f of x by dou y is dou 3y by dou y. What is the answer? 3. Dou f of y by dou x is equal to what? Dou 3x divided by dou x, 3. So conservative. What about this one? Dou f of x by dou y is equal to dou y of 3y. What is this? 3. So f of y divided by dou x is equal to dou x of 4x. This is equal to 4. Not equal. So non-conservative. Right. Okay, children, take another question. Okay, enough with the checking of conservation. Okay, enough. Hold on. Where a question? Okay, a force F is equal to 3y into G. Okay, acts on the body. A force F is equal to plus 3yj acts body and follows the path as shown. So the path as shown. Is the work is given. Path is given. Okay. EA minus 3A 0 1 by 3A. Yes, find it. யாரோ வந்து வேண்டிக் கொண்டிட்டு இருக்கு. Someone is praying. I know who is that. தெரியும். Okay, answer என்ன? 0. Okay, so just checking whether this is conservative or not. அவ்வளவுதானே? Clear? Okay, just find checking whether it is conservative or not. So dou y of 1, whether this is equal to dou x of 3y. This is equal to 0. This is equal to what? 0. So it is conservative, and so the answer is 0. Suppose if it is not conservative, we can find it out, right? We can find it out, or what? Separator? Separator from 0 to A, from O to A when we do. Just like this one we have done now. Work is equal to integral x1 to x2. What we have written here? X dx. So when we do O to A, consider this one. Put the limits from 0 to A. When we do A to B, consider this part. Put the limit from 0 to A. When we do this one, take this one. Put the limit from A to 0. This way, consider this one. Put the limit from A to 0. So in this case, whatever we do, 2 parts will be plus. Another 2 parts will be minus. It will cancel it off. Do this and verify this is getting 0 or not. Not using this method, using this method. Just check each path, make sure you are getting 0 or not. Got it? Okay, I'm winding up the session. Okay, so we have finished up to conservative force. The next session we will start with the work energy theorem, work and kinetic energy, then potential energy. It will go maybe in the next day.